And now we are at a different example. Let's now spend some time reading the wording of the example. So, the following relationship refers to this relationship right here. So the following relationship is known to be true for two angles A and B. So there's angle A and there's angle B. And so the relationship we have is cosine of A times cosine of B minus sine of A times sine of B equals 0.86984. The goal of the problem: express A as an angle in terms of the angle B. So what's primary in this problem is this relationship that we're having right here. So let me now put that in highlights. And so now on my writing board here, let's start writing down the relationship that we've had. Cosine of A times cosine of B minus sine of A times sine of B. And we had this relationship, this expression here, given to be equal to 0.86984. All right, so from this relationship here as an equality, then what I can notice is that, and right now I am not really too worried about getting to the goal of the problem. That's express A in terms of the angle B. So I'm not going to be worried about that goal of the problem yet. Let's now focus on what we can do with this left hand side of the relationship given in front of us right now. So this relationship here, looking at the left hand side, we can notice that this is nothing but just the cosine of a sum identity, because remind yourself, as a reminder here, then cosine of a sum x plus y is the same as cosine of x times cosine of y minus sine of x times sine of y. So this is the fundamental, this is the identity that we are using in this problem right here. And so if we're simply looking at A to be the angle in place of our angle x in the identity, and B is to be the angle in place of our angle y in the identity, then this left hand side of our current equality here is going to be reduced down to, according to the sum identity, then all that here on the left hand side is reduced to cosine of A plus B, and the right hand side remains the same, 0.86984. Okay, and so in other problems, in case you run into a similar problem but having a different relationship here, then the left hand side must be one of the four sum or difference identities that you have learned. And so here the one we have here specifically is the one that on the left hand side is showing the expanded form of the cosine of a sum identity. So now that's what I just did here. The left hand side is reduced to cosine of the sum A plus B. And from now, notice that A plus B, or be aware that A plus B is another angle. It's the sum of the two angles A and B right here. And so now to find the value of A plus B from this relationship, then we have learned that the value of A plus B as an angle can be found by taking the inverse of the value on the right hand side. So now I'm going to take cosine inverse of 0.86984. And so right from here, now we are ready to answer the ultimate goal that was asked from the question itself. So now let me highlight the actual question. We want to express A in terms of the angle B. So that means now on my writing board, the simple step we need to take. And really, I don't even need to find out the actual cosine inverse value of 0.86984 here. We can now just simply understand that this is, or this will be a value, a known real value. But our main ultimate goal here is to express A as a variable, but in terms of B right here. So the simple step that we're going to take next is simply subtract B from both sides. So we're going to consequently end up with A equals cosine inverse of 0.86984 minus B. And so as a goal, we have reached our goal over here. We have now expressed our angle A in terms of B. And so just now, in your responsibility for viewers who view this video of mine right here, that in case you are seeing a problem like this among your web assignments or among any of your assignments being assigned by your instructor, then you might or might not be asked to get the actual value of cosine inverse of 0.86984 right here. And so in that case, if that happens, then just make sure you watch for rounding requirements of from your problem. So here, I'll just do a quick calculation. And if you also, it's now in degrees, then A can be found to be approximately, I'm going to be using about 4 decimal places, 29.5599 degrees minus B. And as I said again, I'm only here showing a generality, but make sure you watch for the instruction from your instructor or your web assignments about how far to round with these answers. So in degrees, you can also write the angle A as an expression in terms of B as 29.5599 degrees minus B. Or if you are asked to express your final answers in radians, then we are now looking at A equals, so cosine inverse of that in radians gives me 0.51592. And here I'm using 5 decimals, but once again, do watch out for your rounding requirements depending on different problems that you are looking at, minus B. And so 3 different ways of how you express your final answer. And now, as a generality, before we close down this example and be heading out for the next example, then I have to point out that there will be in other problems very similar to the one we're currently having here, but the relationship here, the relationship given here could be a different relationship. So what we had here in our problem was the relationship where the left-hand side was out from the left-hand side came out from the cosine of a sum identity. But we also learned about, besides the cosine of a sum identity, and we also learned about cosine of a difference So be aware that your left-hand side of this current problem could be something that came out from the cosine of a difference identity. And so if that case happens, then recall for yourself that cosine of x minus y equals cosine of x times cosine of y, but plus sine of x times sine of y. And then in other case, your problem looking just like this one right here again, but this relationship is showing on the left hand side the identity sine of a sum. So for sine of a sum, then you just need to simply remind yourself that sine of a sum x plus y is going to be sine of x times cosine of y plus sine of y times cosine of x. And the same that can go for sine of x minus y equals sine of x times cosine of y minus sine of y times cosine of x. And in the end, the further important generality that I would like to point out is that in any way how you recognize your relationship in a problem similar to the one we have here on our computer screen to be coming out from an identity, a sum or difference identity. But in the end, after you reduce your relationship, then we should break down to either one of these. And so we should end up with either a cosine of a sum to equals the number on the right hand side, the value k on the right hand side, or we can end up with cosine of a difference equals to a constant value on the right hand side, or we can end up with a sine of a sum to equal a constant on the right hand side, and the same we can end up with a sine of a difference to equal a constant value on the right hand side. And that's the generality of these problems right here, that eventually we're gonna reduce our relationship down to any one of these four cases here. And from once we arrive at that step right there, then simply use the either inverse cosine or inverse sine. And so for this case right here, then we can find x plus y by taking inverse, cosine inverse of k. And the same for this case right here. If we ran into cosine of a difference, then that difference there can be cosine. We can find that difference by taking cosine inverse of the constant value on the right hand side, and so on and so on. So here on my third line right here, then x plus y can be found by taking the sine inverse operation on the k value. And then the same here, x minus y can be found as sine inverse of the value k. And then from there we can solve for one variable in terms of the other one by simply either add or subtract the other variable to the other side. And that is the generality of this kind of problem. All right, so let's now look at a different example problem right here. And let's spend some time reading the wording of the problem to see what it's asking us to do. So using an addition or subtraction formula. Now I have to clarify that the addition or subtraction formula being mentioned here is a different name for the sum or difference identity that we have learned. And so once again, using an addition or subtraction formula to find the exact value of cosine of pi over 12, then cosine of pi over 12 can be equal to square root of a times in quantity 1 plus square root of b all over 4. Find a and b. So now, right at the first look, looking into this expression here, then it has a lot of things going on in that. So my advice, my recommendation is not to be too worried about whatever being written here. So I'm going to remove the highlight. The entire logic of this problem from the beginning to this point right here is as following. The problem is intended that if we were using the addition or a subtraction formula to find the exact value of cosine of pi over 12, then this comma is equivalent to, logically, then this value of cosine of pi over 12 can be expressed as a value in this form of expression. And so in that way, the reason I said let's not worry about whatever going on here is that simply because since the instruction of the problem is telling us to use either an addition or subtraction formula to find the exact value of cosine of pi over 12, then let's spend some time doing that. Let's follow with the instruction here. And so now on my board, cosine of pi over 12. So first thing to look at this angle pi over 12, what I notice, it's not a common angle. And so similar to some examples we have done earlier, similar to the other examples that I have already done, and just like what the instruction of the problem here is saying, we can use either the addition or the subtraction formula to find the exact value of this value cosine of pi over 12. And so that means this is what we can do right here. I see pi over 12 right now not a common or known angle, but I can see pi over 12 as, look at the pi right here, I can see that as a 3 pi minus 2 pi and all over 12. Okay, and even though the instruction said you use an addition or subtraction formula, but really it's intended that we only have to make a choice using only one of those. So here I went with a difference because right now it comes out more obvious for me. So pi over 12 can be expressed as the difference 3 pi minus 2 pi. And so with the rules of algebra, then we can break that entire fraction into two terms. That's 3 pi over 12 minus 2 pi over 12. And that each of these terms reduces down to, the first one here becomes pi over 4, and the next one here becomes pi over 6. And so now what we have done is that we have expressed the angle pi over 12, which is from the beginning not a common angle, but as a difference of two known angles on the unit circle. And so now, and for viewers out there following along with my video, this is not the only way to express your angle pi over 12 as a difference of two known angles. You can find other two known angles, two common angles that the difference also gives a pi over 12. And also for some viewers, expressing pi over 12 as a difference of two known angles is not the only choice. You can also express pi over 12 as a sum of some two known angles. This is what came out from my mind right at this instant. And so now, consequently, cosine of pi over 12 will equal cosine of the difference pi over 4 minus pi over 6. And so in that way, now I can go ahead and use the identity, the cosine of a difference identity. And since we have done this quite a few times in other examples, allow me not to write down the identity again, but I'm going to get straight into using it. So cosine of this difference is going to equal cosine of pi over 4 times cosine of pi over 6. And now the identity says plus, now I'm going to find sine of pi over 4 times sine of pi over 6. And that's how I re-express my cosine of a sum, of a difference, as this lengthy expression here. But now, even though being lengthy, but each of the value being involved in our lengthy expression here, in our expanded form of this identity, is that these are all known values on the unit circle. So cosine of pi over 4 gives me a square root of 2 over 2. Cosine of pi over 6 gives me square root of 3 over 2. Plus, now sine of pi over 4 gives me square root of 2 over 2. And sine of pi over 6 gives me a 1/2. And now we are ready for a final calculation. Now, keep in mind again, let's look back at the problem, the wording of the problem. But the problem wants us to find the exact value of cosine of pi over 12. So that means we must proceed with square roots and fractions being involved here. We don't want to get the actual decimal value of all these calculations. So in that way, be ready that you can be ready for your be ready to reduce fraction and reduce square roots. So first term becomes square root of 2 times square root of 3 over 4. Since we just now simply multiply the two fractions together, it's the rule of multiplying fractions. Plus, the next term becomes square root of 2 over 4. And I had my reason for writing, in case anyone realizing that I did not combine square root 2 multiplied with square root 3 into a square root 6, but instead I left it as a product right here. The reason for that now is that in the next step, now I'm about to bring all of these two terms into one fraction. So adding fraction with like denominators, we can just simply add the two terms in the numerator. So square root 2 times square root 3 plus square root 2 with all over 4, that common denominator. And now realizing that we have a common factor being the square root of 2 right here. And that was the reason why I left my product here without combining into one square root. And so now in my next step, I can factor out the square root of 2 right here to become square root of 2 and in parentheses square root of 3 plus 1 over 4. And so now, so here we have arrived at our final exact value of cosine of pi over 12. However, that is not the goal of our problem. Recall from the wording of the problem that cosine of pi over 12 is equal square root of some a value multiplied with, in parentheses, 1 plus square root of some b value, and all over 4. So let's now give it one more look at our current final answer. So if we're looking at this answer and making a comparison, making a direct side-by-side comparison with the required expression of our problem, then isn't that clear, or isn't that obvious that a must be, see, this is square root of a right here, so a must be 2. That is now our answer. We have found what a is. And this can simply be regarded as 1 plus square root of 3. So our b value is here, b equals 3. And that's how we have found our two final answers, the values for a and b. And so as a generality about this problem, so in case you run into a similar problem where the problem asks you to first use an addition or subtraction formula to find the exact value of your either sine or cosine of some angle that's not common on the unit circle, and then the requirement here and then the problem would indicate that your exact value would turn into some kind of expression similar to something like this, and ask you to find A and B. Then what you need to do is simply follow the calculation for exact value by using either the addition or the subtraction formula, and make sure you are able to do the reduction of square root and be able to combine square root and be able to combine and add fractions, and at the end factor out a square root factor. It will land you into the form that looks like the one that's given in the example problem.